students, you are welcome back to Physics Academy, and in today's video lesson we shall be talking about an interesting topic in physics, which is Newton's law of motion. We shall be looking at the different laws that governs what? Motion, as prescribed by what? Newton's. So without wasting time guys, let's get started. Now from the first law, according to Newton's first law states that every body will continue in a state of rest or of uniform motion in a straight line unless acted upon by an external force. That is, if there is no force, there will be no acceleration. Therefore, the velocity will either be zero or it will remain constant. That is from Newton's first law. Now, Newton's second law says that the rate of change in momentum of a body is directly proportional to the what? Applied force, provided this takes place in the direction of the force, okay? But basically, it states that the rate of change of momentum of a body is directly proportional to the what? Applied force. Now, if we express that mathematically, that will give us force is equals to change in momentum over time, okay? This is what they meant by rate of change of momentum. This is change in momentum. Rate of it is now the reason why you have over time. How that is clear. So this is first formula for finding force. It can also be used for finding the change in momentum, and it can be used for finding time. Now, if you expatiate this further, momentum is mass times change in velocity. Now, why am I introducing the change? It's because of this delta sign. If there was no delta sign, it would just be simply mass times velocity. So because of this change sign you are seeing here, it will now be expatiated to give you mass times change in velocity over time. So this is another second formula for finding what? Force. Now, if you expatiate this change in velocity further, you will have v minus u, where v is what? Final velocity, and u is what? Initial velocity, all over what? Time. So this is another formula for what? Finding force. You can also use this formula to get the what? The final velocity or the initial velocity. Why this formula can be used to get what? The change in velocity alongside the what? The force. Now observe something here. This is change velocity over time. And we know from our basic knowledge in physics that acceleration is the what? Change in velocity. Is it not the rate of change in velocity? So this guy here, change velocity over t, can be replaced by what? A. So a new formula for force is now what? Force is equals to mass times acceleration. And this is the what? Standard formula for finding force. So take note of all these different formulas outlined here. Now we move on straightly to what? Newton's third law. The third law according to what? Newton's. It states that for every action force, there is an equal and opposite reaction force. That is, if you should use your hand to hit a wall, there will be a force that will also act on your hand. Is it not? That's why you feel pain when you use your hand to what? Blow a wall. Is it not? Because there's a reaction force acting on your hand also. Now, if you express this mathematically, FA is representing action force. FR is representing reaction force. So why is the sign here? Why do I introduce the minus sign here and I do not add minus sign here? This minus sign here is showing that what? They are in opposite direction. The action force could be coming this way, while the reaction force is coming this way. You can also interchange it and say the reaction force is equal to what? Minus the action force. Why am I introducing this sign here? Because they are in opposite direction. Is that clear? So now we know this as our background knowledge under Newton's law of motion. Without wasting time, guys, we'll be taking the questions, some questions under Newton's law to see how they are being solved. So let's get back to that now. Now, reading the first question, it reads, a constant force acts on a body. We don't know the value of the force, right? It was not given. It acts on a body of mass 5 kg. Now, one thing I advise when you are solving question in physics, every quantity that was given in the question, ensure you what? You derive all of them out. So we'll do this like this, solution. Now, we're told that a constant force acts on a body of mass 5 kg. That is for mass, is it not? So M was given to be what? 5 kg. Is it not? Good. They now said, and changes its speed. That is, there was a change in velocity, is it not? From this to this. So which is the initial speed? Is it not this? And which is the final speed? This. Because they said from 20 meters per second to what? 90 meters per second. So this is the initial velocity and this is the what? Final velocity. And like I said, initial velocity is represented or symbolized by what? U. So I will say U is equal to what? you seeing that? Then our V, which stands for what? Final velocity is now what? 90 meter per seconds. Now they gave us a time. They said this change occur in 10 seconds. So come here and write T is what? 10 seconds. Now let's see what the question is asking us to find. They said calculate the magnitude of the what? Applied force. That means for this question we are asked to find the force. The force is unknown and we are asked to what? Find the force. So these are all the derivatives, and this is what I meant by when you are reading a question, all the quantities I was given, ensure you derive them out. This is basically what I have done here. Now look at this question. What are we asked to find here? We are asked to find the force. It's the one that is unknown. Now we basically know that this question was taken from the topic called Newton's law of motion. How do we know that? We are seeing that a force acts on the body and it causes a change in the velocity of the body. Is it not? That's basically what this formula was describing and what this law was describing. That there is a change in momentum of the body whenever there is an applied force. So this scenario is what? Newton's law of motion. Now, which of the formula will go for this? You have to be able to pick your formula very correctly, okay? So that you won't make mistake. Now, observe that we have initial and final velocity in this question. Can we use this formula? No. There is no initial and final velocity in this formula, so you cannot accommodate it. Now, can we use this formula? We are not given the change velocity direct, so we cannot use this formula. But can we use this formula for force, to find force? Because here there is a space for final velocity, and there is also a space for what? Initial velocity. So this will be the right formula to use. Then you bring it in and write force is equals to mv minus u over t. So this is the formula we'll be using. We are given all this, and we're going to be using this formula to find the applied force. So now we have this. Next thing next is to what? Impute the value of all the quantities you were given into this formula. So let's do that together. Do we have a value for F? No. So F will remain F. That is F, which is force, is unknown. Is it not? Good. Now ask yourself, were we given the value for mass? The answer is what? Yes. So it's 5. We come here and put 5 in brackets. Now what is our V, final velocity? 90. Now mind you, when you are imputing the values into the formula, you don't put the units so that you will not cause some complexity, okay? Just put the values only. Provided the units of the quantities are in their XI, that is, they are in their standard unit form, okay? They what they call XI units, standard international units or international standard of units. Ensure that each of them is in their international standard of units. For mass, it is kilogram. So if you are giving the mass in gram, you have to first of all convert to what? Kilogram. For what? Velocity generally, this to their velocity. For velocity generally, it's what? Meter per second. So if you were not given as such, you have to convert first. Your time must be in seconds, and your force, when we have calculated for it, it will be in what? In Newton. So these are what? Standard units. So let's progress. What is our final velocity? 90. I will come here and write 90 minus, because I'm following the formula. What is our initial velocity? We're told as what? 20. So I'll come here and write 20. Close the bracket, because I'm following what was given based on the formula. Then over time. What is the time from this question? It's what? 10. So time, the time here is what? 10. Now we are looking for F, and this is what we now have. Now watch out what will happen. It will now be equals to, mind you, this 5 is outside the bracket, so I'll put it separately. 5 times, ask yourself, within this bracket, what do you have? 90 minus 20. Is it not? Class, 90 another question on this topic called Newton's law of motion. Let's get down to that now. Alright, about now we shall be taking the second question under Newton's law of motion. So let's get down to that now. Now let's look at this question together. It reads, when taking a penalty kick, a footballer applies a force of 30 newtons. Solution. Every quantity you see, derive them from the question. We're told that the footballer applied a force of what? 30 newtons. So come here and write F is equals to 30 newtons. Are you seeing that? Good. Then for a period of 0.05 seconds, 0.05 seconds is standing for what quantity? Time. So we say time is equals to what? 0.05 seconds. Then what else? Then I said if the mass of the ball is 0.075 kilogram. Now, mass M was given as what? 0.075 kg. Okay? Then what else? They said calculate the speed with which the ball flies off. We are asked to find the V. Okay? V is unknown. From this question, you can call it change in V. It's the same thing. Now observe something. Ensure that all that you have is in their standard international units. Is first in the right unit? Yes, Newton is it. For time, it was second. For mass, is what? Kilogram. Is it not? So all of them were given in their standard units. So we are going to proceed. Now ask yourself, which formula can you use that will combine or have all these quantities in it? The formula is force is equals to mass times change in velocity over time. Mind you, when they said calculate the velocity with which the ball will fly off, it's the same thing we're referring to by change in velocity. Okay? So now let's impute and solve. Where was the force given in this question? Yes. And what's the value? 30. So I'm going to write 30 equals to, following the formula, N. What's our N? 0.075 times change in velocity is unknown. Okay, change in velocity is what? Unknown, or you call it V. All over. Now, was the time given? Time was given as what? 0.05. Is it not? So this is what we now have. So working from here now, how do we make change in V subject? We can choose to what? Cross multiply. Or let's do, okay, let's just cross multiply from here. When you cross multiply, this will times this, and this will be on its own side. So you now have 0.075 times change in V equals 30 times 0.05. So this is what you will now have. Okay? So if you work this separately, divide both sides by this to make change in V subject. You have 0.075 over what? 0.075. 0.075 will cancel this. So what we left here is what? Change in V equals to what? 30 times, you have 0.05 all over 0.075. Okay? If you work this out with your calculator, you can double move 1, 2, 1, 2. So what you will now have is what? 30 times 5 over what? 7.5. Okay? Now when you finally do this with your calculator, it will give you exactly 20. And mind you, we are asked to find the velocity with which the ball will what? Move off. What is the SI unit for velocity? It is what? Meter per second. So this is the answer to the question we are asked to solve. So clearly, I hope you understand how questions on Newton's law of motion are being solved. So now I'll be giving you guys a question to try your answer on. Let's have the question now. Alright guys, here is the question you are asked to try your answer on. It reads, what change in velocity would be produced on a body of mass 4 kg? We are giving mass. If a constant force of 16 Newton, you are giving force, act on it for 2 seconds, you are giving what? Time. And what are you asked to find? The change in velocity. And that is symbolized by what? Delta V. You are asked to find the delta velocity, that is change in velocity. So do well to try your hands on this question and let me know what you think the answer is in the comment section. Don't forget to share my videos with